Alright, welcome to my tutorial on how to build an Oxbow hammer. First we'll take a look at the anatomy of a hammer. There's 7 parts. First we have 2 heads, one at either end of the hammer, and they're connected by a rope which we call the tether. Along the tether there are 4 nodes which help us position our hands as we play. The 2 outer nodes are called poi nodes, and the 2 inner nodes are called bridge nodes or shoulder nodes. Between the poi nodes and the head, we have the distal tether. Between the bridge node and the poi node, we have the medial tether. And between the center and the bridge node, we have the proximal tether. The bridge is the space between the 2 bridge nodes. And the yoke is the span of the tether between the 2 poi nodes. We also have what we call the wing, which is the span of tether between the bridge node and the head. Next, let's talk about how to prepare tethers for our build. We're going to talk about cutting them in particular because it can be challenging. So here's our tether, and we're not going to use scissors to work with them. They're too messy. And let me just take a moment to point out the nodes here. So we have a large node and a small node, and their profiles are designed for different use cases. The high profile node is good for lots of things. The low profile node is mainly good for rope dart, where you need your hand to slide smoothly through the node. The tether is a 1/4 inch thick, or 6 millimeters, and I don't recommend going any larger than that because air resistance becomes a big problem, and the hammer will feel mushy when you spin it in meteor mode or dart mode. So we're going to cut it here, get back to cutting. When we cut these tethers, they will fray badly, and we won't be able to get the nodes back onto the tether. So we need to treat it somehow, and the best way to do this is with heat. So we're going to melt the area around where we want to make the cut, and this will shrink and seal the fibers in place, and we'll end up with a nice tapered end that we can use to mount the node without any sort of frays getting in the way. So go ahead and cut it here, and you can see that the result is a nice clean tapered finish that will make mounting the node much easier. Okay. So next I'm going to show you another type of fiber. This is a high-performance fiber called Dyneema. It's very, very strong and very stretch-resistant, and it has a wonderful feeling on the skin. The problem, again, though, is we can't get the node on until we prepare the end. And the problem with these advanced fibers, like Dyneema or Technora or Kevlar, is that they don't melt. They actually sort of burn. This Dyneema does melt a little bit, but it mostly burns. So when I try to cut it here, which by the way is pretty difficult, these are very strong fibers, you'll see that we tried melting it, but that's not going to work. So the alternative is to use tape. And when we use tape, I typically do about a 1.5 turns to keep it from getting too thick. And then I pull very hard on, this is electrical tape by the way, pull very hard on it to sort of pack it all down. And now when I cut it, again it's difficult, but you'll see that the end is nice and sharp and clean, and it makes it so that the node will fit into the fit over the tether. Alright, now it's time to talk about mounting the reference head. So we're going to mount one head to the end of our tether, and this will be used as the starting point for building the remainder of the hammer from that end, moving across the tether. So first we'll mount the nodes. I'm going to use blue nodes for the poi and yellow nodes for the bridge. I treated the end of the tether using that melting technique, and you can see that the nodes are sliding on easily. Remember that the tether is 1/4 inch thick, or about 6 millimeters, for like optimal air resistance. And now we're going to start working on the head. This is the outer shell. It's a rubber. And we use a cartridge system to hold it all together. And you'll see how that works in a moment. First, we'll make a mark where we want our stopper knot to go. And the stopper knot is used to fix the tether inside the cartridge. So we made that mark. We're going to tie the stopper knot. It's a simple overhand knot. And we're going to make it really tight so it doesn't creep on us after we've closed everything up. Just enough to fit in the cartridge, plus a little bit. We're going to open the cartridge and place the tether inside with the excess facing out. And then we'll add an O-ring, an elastic O-ring, and we're going to slide it all the way back to the inboard end of the cartridge, like that. And now it's spring-loaded, so it's all held together while we work on it before we close it up. I'm twisting the tether so that it sort of retracts into the cartridge, and now I'm adding a weight. This will be a 160-gram head. I recommend somewhere between 150 and about 200 grams. Adding this little decorative sticker to the end, followed by the final O-ring, which holds it all together. And then we can just pull the cartridge inside the shell. So that's our mounted head. And now we're going to remove it and demonstrate adjustment. So first I pry it with my fingers and then push it with this Sharpie. A Sharpie makes a really good tool for a lot of the work you do while you're building the hammer. First we're going to pull the end O-ring off and dump everything out. Remove the tether and the stopper knot. And you'll notice I didn't remove the other O-ring just to keep things together. Making a mark where we want our new knot if we want to adjust it. And you'll see we're going to slide the knot over after loosening it. So we're taking some of that excess tether that we had sort of stuffed inside the cartridge, and we're taking advantage of it to change the length of the tether. Moving the knot out would make the hammer longer, of course. We're adding that weight back in, adding that decorative sticker, and replacing the O-ring. Again, this is a 160-gram head, and somewhere between 150 and 200 grams is good. 160 is a good starting place. There you go. That's how you mount a head. Now we need to talk about setting the first poi node. So we're moving along the hammer from one end to the other. So we have a sliding node, and we have the head mounted. What we're going to do is hold the node between our thumb and pointer finger so that the node is in line with the tip of our thumb. Like this. We can then pull the tether in either direction through the node while we hold it. We're going to place our elbow on the table with the head sitting on the surface of the table, and we're going to carefully pull the tether through the node until the distal tether, or the poi section of the tether, is taut. Like that. We're then going to use a screw to mount the node to the tether, but we're not going to drive it in all the way. We're only going to drive it in about halfway, and this is to prevent damaging the tether while we build the hammer, in case we need to make adjustments later on. So that's our first poi end finished. Moving along the hammer, we're going to skip the bridge nodes for now and go to the second poi node. We need some space to do this, so you can go outside or into a big room or something. We're going to go into the standard Oxbow position, which is a position where we wrap the tether around our body in this way. that you see here. So it's sort of a spiral around our arms and around the back of our neck. We're going to hold the poi node just like we did before when we were setting it. So it's in line with the top of our thumb. Again, the head should be parallel to the bottom of our elbow. So now you can see that the tether is loose right now. What we're going to do is tighten it. And we're going to tighten it quite a bit. Pretty tight right now. It'll probably end up being tighter in a second here. So we're holding both ends, tightening the tether as we go. Holding on to the tether, we're going to slide the other side, the other poi node down, and we're going to put it right where we're pinching, just like that. Same thing, thumb in line with the node. We're going to drive the set screw in about halfway just to hold it in place. And now we're going to start adjusting it as we need to get it just right. We're going to check everything's squared up, make sure the tether's tight while we're holding the nodes in that nice flush position. I found it to be a little loose in this case, so I'm going to move the poi node in slightly. So when I hold the node now, when I hold both nodes, because they're closer together, it'll be tighter around my body. It's quite tight now. Still flush with my thumb. Now when I move my hands down, you'll see that the node rises up towards my wrist. Same on the other side. And this is correct. This is the way it should be. It should be in line with the base of your wrist, right where that crease is in your wrist. So up, it's going to be tight, flush with your elbow. Everything looks good. Down, it's going to be up towards your wrist. We'll now mount the second head to its end of the hammer. So we have the two blue nodes, those are the poi nodes, and we've set them into their respective positions, feeling pretty good about it. And now it's time to mount the second head. So the first thing we're going to do is remove the first one. Again, using a Sharpie to push it out is a great way to make it simpler on yourself. We're going to remove the inboard O-ring, just slide it back, break the shell open, pull the knot out. Now we'll remove the head. So our objective here is to make both poi identical, exactly the same length. And to do this, we're just going to use our Sharpie again to mark right where the first knot we tied is located. Just going to make it right in line. Make sure those nodes are straight. Right in line. Right there. And we'll tie another stopper knot. Nice and tight. So now in theory, both knots and both nodes are exactly the same distance apart. Here I'm just going to demonstrate trimming the remainder, the excess tether off. Generally you would have a lot more excess. I just had a shorter tether than usual. But you would trim the excess tether away so that it fits inside the cartridge. Now we're going to mount both heads on. Oops. There we go. Now remember that these are adjustable. So those stopper knots can be repositioned as necessary to increase or decrease the length of the poi. Again, you'll see that I use the O-ring, I push it all the way back so that it's like spring-loaded, and that way I can easily work with getting the weight in and keeping the excess tether out of the way. We're going to add that little sticker again. And the final O-ring. And there we have it. So both poi are finished now, and this establishes the total length of the hammer. Everything's lined up. Now we're going to set up the bridge. So to do this, we're going to start working with those two yellow nodes. We'll need a marker. The first thing we need to do is make sure the hammer is perfectly parallel and perfectly mirrored. So to do this, we're going to line up the heads, line up the nodes, get the bridge nodes out of the way, sort of move them apart from each other a decent amount. Line up the poi nodes so that they're perfectly in line. And then we're going to carefully slide along both tethers. So that it's perfectly mirrored. So now we've arrived. This is the exact center of the hammer right here. We're going to mark it. And now we need to center the two bridge nodes on either side of that center point. Okay, so we've got them roughly in position. Now we need to determine how far apart to put them. And a good rule of thumb is to use the length of the poi segment. So laying this down, we're going to adjust the two bridge nodes from the center so that the inner edge of both of them just meets the outer edge of the poi. We're going to fold the hammer in half, and then we're going to work both nodes so that they're lined up with each other, but we're just going to split the difference. So we're going to move one in and one out equally until they're perfectly in line with each other, and then we'll double check and see it's perfect. So then we're going to use the set screws to hold the nodes in place, but we won't drive them in all the way, just in case we need to make adjustments later on. Great. So there's our bridge. We'll now check to see how the hammer plays in various modes. So to start with, let's just verify that the hammer is well mirrored. So I'm going to fold the hammer in half and match up the heads with each other. And then I'm going to check to verify that the poi and bridge nodes all line up with each other simultaneously. So that's a good mirror. And now we're going to put on the hammer in the standard Oxbow position, making sure to lock the tether behind our elbows like this. And you can see from behind how it locks around the elbow. Okay, now we'll lower our hands to our sides, and we'll check that the poi nodes line up with the creases in our wrists as they did before. We'll then pinch the poi nodes and raise our hands to our sides with that 90-degree elbow bend, and verify that the heads line up with the base of our elbows. Hands back down, we're going to check the dynamic fit of the hammer now. So we're going to pinch the distal tethers And it's very important to understand that you don't use the nodes as handles. They're more like texture markers that help you stay oriented along the playing surface of the tether. So we're holding the distal tethers, not the nodes, and we're going to start spinning in poi mode here. And it's okay if you don't know how to do any of these movements that I'm going to show. Just know that we're checking the length of the hammer, and in this case, we're checking the length of the poi. So the poi this is a good starting place at this length, but if you want to make them longer or shorter, there can be consequences that we'll go over in a little bit. Hands over the head, I'm doing a windmill, and you can see that the yoke is slack around my shoulders. From the back, you can see the yoke is slack, and that's normal. In fact, the poi are longer than they are when my hands are down at my sides. So if I stop and open my hands, right, we've got the poi nodes in that standard wrist position. But if I move my hand up, the poi actually slides between my fingers outwards and gets longer. And now you'll see that the node is in my hand. When I move my hand down, it slides back, and now the node is at my wrist, and now it's in my fingers, and now it's at my wrist. So it's important to have a nice loose sliding grip on the tether. We're going to escape now into a meteor weave, and we're going to check for ground clearance. So when the meteor is rotating, there's a center of rotation, and we want that to be in line roughly with our shoulder. That's a good comfortable position to have it in. And so that's our objective. Now, there can be problems with this. If we decided that the poi were too short and we wanted to make the hammer longer, then we might run into a situation where we'd be hitting the ground when in meteor mode because the hammer's too long. So I'm going to hit the ground intentionally here. So if the hammer was too long, we would be hitting the ground. And so you you would have to hold your arm up to maintain ground clearance, and that's pretty much unacceptable. So you'd have no choice but to shorten the hammer, which means that your poi would be shorter. And this can be a thing, especially if your upper body is bigger. Like if you have a lot of muscles in your shoulders and arms, the tether has more to wrap around. So you have to find a good balanced compromise between poi length and meteor length. So now I'm doing some dart stuff. I'm holding the dart by the bridge node and placing the head by my hip. And I'm checking for ground clearance here. Generally, you want that 90-degree elbow bend again. I'm going to do a more advanced movement now. This is very difficult to pull off with a hammer that's too long. Some moves are just impossible if the hammer's too long. So all this stuff is good. I'll do a neck roll. That's also one where I hit the ground a lot. So this is looking pretty solid. I feel really good about where the hammer sizing is at right now. And then one last thing I'm going to do is a finger rotor in the horizontal plane. And you can see, so I'm checking the bridge length right now. You can see my finger is notched into one of the bridge nodes as I do the rotor. And I'm checking to feel the sliding action and the friction of my finger as it rotates around the tether. This is kind of a rabbit hole as far as like how to place your bridge nodes, but basically the further apart they are, the more leverage you have, and that can be beneficial up to a limit, and then you start losing control. So yeah, I think that's about it. This hammer definitely fits me well, and you can see how I was able to do everything. So yeah, so the hammer's essentially done, and all we need to do is commit the nodes. So to do that, we're just going to drive the screws in the rest of the way, and then it'll be finished. So keep in mind that the screws do mar the tether ever so slightly. So if you choose to move them, there will probably be a little bit of fuzz left behind from where they were prior. And that's it. So I say this tutorial is basically done. Yeah, you're going to form a relationship with the prop, and it's going to sort of change with you over time. You'll potentially move the nodes a little bit here and there. You might make the tether longer or shorter. Longer if you want to focus on poi maybe, and shorter if you want to focus on meteor and dart, those sorts of things. But yeah, so thanks for watching my tutorial, and I sincerely hope you enjoy the prop. Thanks a lot, and hope to see you out there.